Hello, my name is Keith Parsons, and today we're going to talk about the Wi-Fi stress test. This was a vendor-independent access point analysis brought to you by Wireless LAN Professionals. We're going to talk about two types of testing. And this is stress testing. One would be an egg drop. In elementary school, kids get an egg, they bring it home, and they have to take something from home and build a little safety area to protect the egg for when you drop it. Where my kids went to school, they dropped it off the roof. And they wanted to protect the egg was the goal. A second type is a popsicle stick bridge. This usually something happens in high school in a technology, drafting, perhaps engineering class, where you want to take a set of popsicle sticks and span, in this case, half a meter or so. And we wanted this to see who can take the most stress. Two different types of tests. One is to protect, one is to break. And we want to find out the breaking point. The egg drop test, where you protect the egg, it's kind of like what a lot of vendors do with their access points. What they want to do is protect their AP. What they want to do is design a test so that their access point always wins. Well, of course it does. If your job is marketing or sales for a specific vendor, your job is to make sure that everyone thinks your AP is the best access point. Well, to do that, they don't really want to break their access point or show it failing at any point. What they want to do is make it always win. Kind of astounds me that every access point manufacturer can run tests, and amazingly, each test they run, each manufacturer wins their own test. And you know that's mathematically impossible, and yet somehow the marketing guys think we're going to believe that. To do that, they use some very sophisticated automatic testing tools where they don't have a lot of bodies, they just have scripts running, and they can tune those tools so that their individual AP can hit right in its sweet spot. Well, that is not what we're going to do here. Not the type of test we've got. In our test, our goal is to break access points. Now, in some of the edits I had people do for me, they said, don't say we broke an access point. You didn't actually break it. No, we took it to the breaking point where data couldn't flow anymore. Like the high school bridge. When they took the bridge and you designed it with the same 50 popsicle sticks, but depending on your design, some could take more weight than others. What we've done with our test is we made this Wi-Fi stress test where everything stays the same. Instead of 50 popsicle sticks, we had 30 iPads, 4 MacBooks. The room was the same. The FTP server was the same. The FTP client was the same. The iPerf server was the same. Nothing changed except for the access point. And now we're going to push it until that access point breaks, until it can no longer send data. At Wireless LAN Professionals, we are trying very hard to be as vendor independent as possible. So we took no payments from vendors, no gifts, no little issues coming to us. All of the testing equipment, all of the iPads, the MacBooks, the servers, the racks, cabling even, everything was purchased by Wireless LAN Professionals for this test. We used more than 30 volunteers this week. A week-long test, a bunch of different came in. Some people came the entire week, thank you very much. Some came for just a couple of days. We had observers and volunteers from 5 different school districts, 2 universities, 7 access point manufacturers, and even 4 competing resellers showed up and worked together. And that's the idea. We all worked together to learn from what was going on. Now, the marketing guys, they probably didn't enjoy working together. But the technical guys were like, hey, can we do this more often? How often can we get a chance for technical folks to hang together, talk about Wi-Fi, look at the nitty-gritty of how things work, and just hang out as Wi-Fi professionals? It was wonderful. And I think we're going to plan more of these in the future, if not to do more tests, just to sit and be together and learn together. We wanted this test to be repeatable. So it wasn't just Wireless LAN Professionals using a very specific tool and we were in some lab someplace. This was all open. So we used open tools. FileZilla for FTP. JPerf is the front end for iPerf. We even used HTML5 for video streaming instead of some of the built-in players that are there. An iPad has built-in players. It has a built-in video player, but it needs a local device. I could use Dropbox or something, but we wanted to show streaming. It has a YouTube player, but we chose not to use the YouTube player because what we wanted to see was traffic from AP to the client. We wanted to take out of the equation the internet connection and variability that might have happened out on YouTube. Because we're using the internal Safari browser, it doesn't support Flash, so thus we had to go to an HTML5 player, and we contracted with a web design company to build us an HTML5 player that you could just click and it would download and stream the video to the iPads. Well, why do we do this? Well, it's to really answer the questions from our customers and your customers and people who say, well, are we ready for the one-to-one initiative? Some of our K-12 customers come to us going, my district officers are asking us, are we ready for one-to-one? Can our wireless infrastructure handle it? We need to answer that question. Can we handle 30 iPads in a single room and they're streaming separate video, not a multicast video, but individual videos? Can your AP do that? Well, we need to find an answer for that. Or a question, how much traffic data flow can one access point handle? Another question would be, how many clients can one access point connect at the same time? And so we have some other questions that are out there. We didn't get a chance to answer this round of tests, but we'll be looking at those in the future. And the last question I wanted to talk about here was, well, aren't all access points the same? And the answer, resoundingly from our data set, is no, all access points are not the same. We designed this test to be simple. It had one goal, to find out if we could take an access point and push it with as much throughput using FTP and iPerf and video, streaming video to iPads, and we could take it to its breaking point. That was the design. And it's really simple. We didn't test all other things. We didn't say this test we're doing here is the end-all, be-all, the wonderful, perfect test you're going to want to have to tell you which AP is best in the world. It only tests these two little items, throughput and video. There's other things we don't touch on. What we designed was an environment with iPads, MacBooks, servers, cabling, room, everything stayed the same, and the only thing we changed, we rotated out the test access points. Now, of course, there's lots more we can do. A lot of other tests we're looking at in the future. If you have some ideas, go ahead and contact us at Wireless LAN Professionals. We'd be glad to put them in the queue and have that as something else we're going to test in the future. Already, we've received complaints from people going, wait, you didn't do this test right. It didn't test X. It didn't test Y. It didn't test Z. You don't have multiple APs in a room. How often is there a single AP there? Well, I don't know. Maybe in a hotspot, but not in schools or in universities. It's not very often you have a single AP that you have to support. There are multiple APs. And we're admitting we didn't test multiple APs. We only tested one AP at a time. We wanted to test the AP itself, take it to its breaking point, as well as test the RF. The RF frequency has a capacity, and we wanted to see if we could push that capacity. Other complaints have been, hey, this isn't real world. How many schools want to run 30 iPads with separate videos in the same room? Actually, we had quite a few school districts ask for that. They want to be able to run their iPads. 30 just happens to be an arbitrary number that fits in most of their cases, and still have some Wi-Fi capacity at the same time that the iPads are going. So that's what we designed the test for. Rather than jump ahead, and I'm sure some of you watching this are going, get to the rankings, we want to know who won, like this is a win and a lose scenario. More important than winning and losing is the things we learned. We learned that cable trumps Wi-Fi. Well, yeah, we knew that. Wi-Fi is a shared medium. Yeah, we knew that as well. 40 megahertz is better than 20 megahertz. Yes, that's true. All access points aren't equal. We might have been a little thinking they're mostly the same at layer 1 and layer 2, and that's what we're testing, and yet we can see they're quite different. We also learned band steering, or some people call it band balancing, load balancing, are fairly important to be able to push the most amount of traffic through any one individual AP. We learned that frequencies themselves, the frequency carries has a limited capacity. And we really learned that having professional tools on site really helps you as a wireless LAN professional do your job better. It lets you see into layer 1 and layer 2 way better than using regular networking tools. So let's get into the details of these. First, Ethernet trumps Wi-Fi. I know you're like, well, of course. Well, in our test, we started with a baseline where we connected a cable up to the FTP client and did the upload and download, and a cable into the iPerf cloud and did upload to see whether or not we could set it as a baseline. In our example, our baseline wired was between 3 and 4 times faster across the board than the fastest AP that we ever tested. Wires allow you to have a switch access. So there's no contention. There's no contention domain like we have in wireless. No collision domain going on. So obviously, this makes a lot of sense. But what we want to emphasize here is when you're applying Apple TVs into your network, think really strongly about putting them on Ethernet. It'll make a big difference. Apple TVs have even more load they put on the network, on the Wi-Fi network, than you'd anticipate. So think about Apple TVs for wired. Next thing we learned, that's kind of just a confirmation of what we knew already. And for years, I've been talking about access points to customers, clients, students. And I give an example of, is an access point a repeater, a bridge, a hub, a switch, a router? And people, raise their hands and answer differently. What do you think it is? An access point is always a bridge on its wired side. The side that goes to the wired network acts as a bridge. From the network standpoint, it sees the access point as a bridge. In the air, however, out on the radio side, it's a hub. So an access point is a bridge on the wired side, a hub on the wireless side, and what we're testing today, in these tests we've been doing, was all on the hub side. It's the wireless side. Every device in Wi-Fi has a specific frequency it uses, and that frequency has to share with everyone else. Wi-Fi is a shared medium. We've kind of, as networking professionals, lost the idea of thinking about a hub collision domain network because we haven't touched it for so many years. So we get a little confused, and we think of things like VLANs and SSIDs and QoS as some way to help us manage all that traffic, and yet in the wireless hub side, VLANs, SSIDs, QoS don't have hardly any change at all in how things work. Yet on the wired side, they do a wonderful job. In fact, adding multiple SSIDs onto a single Wi-Fi lowers your available throughput because we're adding more beacons in the air and not getting anything back. So putting a VLAN on a wired network is great, but assigning a VLAN to an SSID on the wireless is also good. It can do wonderful things for you, but it does not get rid of the fact that it's a shared medium and everyone has to share the same frequency. 20 versus 40. Yes, we all know 40 megahertz wide channels are bigger than 20 and they carry more data, twice as much data. So as one of the tests, we were going along, we had a vendor who was doing a config on their access point and they weren't quite ready yet. So we grabbed an Airport Extreme from Apple, hooked it up, and it was set to a default of 40 megahertz, had no band steering whatsoever, so it only used one radio, happened to be channel 36 in this case. And when we ran the test, it had the absolute fastest aggregate throughput. Even though it was a SOHO device, just doubling the bandwidth was enough to make it be the winner in all throughput tests. In fact, if you cut the throughput of the Apple in half, it was still the fastest throughput. Then we thought, well, how could it be faster even in half? And then we realized that iPads were V4s, meaning they could use the 40 megahertz channels, and each iPad, when it was downloading video, took its little slice even faster. So even though they're on the same frequency, we couldn't use this and compare it to others that were tested at 20. So thus, we didn't include the Apple Airport Extreme in any of our averages or any of our tests. But just as an example, if anyone ever asks you, hey, you're a wireless LAN professional, what access point should I have at home? Good answer would be an Apple Airport Extreme. As you can see in the graphic, it had higher throughput. The blue line is the throughput compared to average. The little kind of dark gray line at the bottom is the average throughput. Even if we cut the throughput in half to the green line, it was still way better than average. And their throughput on their videos, fewer video errors. The red line for the Apple was further to the right than the average. So did a fantastic job. But again, we can't use it because it was 40 megahertz. Perhaps sometime in the future, we'll be running tests 20 versus 40 and be able to give you some more answers on that. Now, access points are not equal. You knew they weren't equal on price. You knew they weren't equal on a 3x3 versus a 2x2. You also knew they weren't equal because each access point has other features. Architecture, manageability, ease of configuration, ease of connection, price, etc. And so we knew there was differences there, but we didn't expect to see as much of the differences we saw under a no-load situation. When I say no-load, we took an access point, the test AP, connected it through a wire to a switch. On the other side of the switch was an FTP server. We then took a wireless client, happened to be a MacBook Pro with a 3x3x3 chipset, could handle up to 450 meg if it gave it that much, and we downloaded files. We did an FTP down, we did an FTP up, then we went over to a different MacBook and did iPerf. Under no-load situations, there was no other devices on those frequencies in the room. And yet still we saw a wide disparity between the worst and the best under no-load alone. Now, a little disconcerting from a Wi-Fi professional going, wait, hey, most of these had the exact same chipset in them. The only differences were what a vendor did for antennas, low voltage power, low power amplifiers, firmware, how their calculations worked, and yet we saw wide variability. Almost, in fact, more than double the speed from the lowest to the highest under a no-load. We also looked at RF analysis and spectrum analysis and saw their radio spectrum. When you look at it, they were all running OFDM, so it should have been a nice flat top with the little subcarriers in there. And what we actually got was some of them had rounded corners, some of them weren't quite equal, some of the radios weren't performing as good as other radios, even with the same chipset. So we saw wide variability, not only in throughput, but also in how they use the radio. Band steering. Band steering's, well, some people call it load balancing or band balancing, however the vendor wanted to put it. What it means is, as clients come on, do they go to 5 gigahertz or do they go to 2.4? Now, what we'd like, and we saw most of the vendors who performed better, they had a nice balanced load between where they go. Some vendors had a nice little nerd nod that said, we want a 60-40 split, or we want a half and half, or run 20 first, and then after the 20, move them all over. And they had different ways of doing this band steering, but we saw quite a substantial effect when this happened. One of the things we saw with it, and this is a spectrum analyzer showing here, on the first side, the spectrum analyzer is showing it's fully saturated. The signal coming off of here, totally saturated the time. There was no time slices available. Now, both of these are same amount of time, same number of clients that are on the network, same FTP that's being pushed. The only difference is an access point. And you can see here one access point outperformed the other because it had available time slices. It wasn't saturating the signal. Part of why that was true was how each AP used the medium differently. Two other examples. Same scenario. This one happens to be under 15 iPads plus FTP was going on at the time. One access point was running 83 meg. That was its average connection rate. Another running 49 meg. This was its effective data rate. Now, it's a combination of what was going on the iPads and what was going on the FTP client at the same time. And so that's why it's kind of a weird number in there. And it's an effective data rate, not an individual rate. But if you look at they're pretty close to the same, 12% and 13% retries. But look at the difference in their time. Because it's more efficient, the blue, by the way, is data. Because it's more efficient at sending data, the orange, or control in this case, isn't taking as much time. Because it doesn't take as much time, it's easier to get more packets on the air at the same time. That's how the firmware was working in there. Even with the same amount of retries in the air, how one AP was able to push more data at the exact same scenario as another one is one of the things why we know access points are different. Another thing we learned was the RF spectrum itself has a limited capacity. And we've read this, we've seen this, but while we're doing these tests, we proved it. When the utilization of any one frequency got too high, all access points died. It wasn't like anyone was magic and could break the laws of physics. Different access points deal with this density differently. They take the same issue. We have a limited supply. And how well they used that limited scarce resource allowed some APs to last longer, support more iPads than someone else. That's what we're talking about in differences between access points. How well they use the exact same resources and obviously change the results. Now here's a soapbox. I'd go climb up on top of my soapbox or say, set soapbox equal on, and then talk. I think as wireless LAN professionals, we need to be using the correct tools to see what we need to see. We normally, from a networking standpoint, we think about the network layer, ping. Ping is a great tool for a lot of things. Ping is a terrible tool when it comes to Wi-Fi because ping is a high upper layer tool, and we need to see, when we sent the ping, how many retries did we get? You're not going to be able to see the retry rate or the CRCs in normal networking tools. You also won't be able to see the raw RF spectrum. So what we used during this test was a couple tools from MetaGeek. We had 2 copies of Channelizer, actually 2 DBX Pros. One was on 5 gig, one was on 2.4. In order to get them to both show up on the screen at the same time, we had 1 copy of Channelizer, 1 copy of Channelizer Pro. Each instance was running a different frequency. We also used IPA. Right. Okay. We also used IPA from MetaGeek. IPA is a packet analysis tool. It doesn't capture its own packets. We used other tools like MacBook it was on, happened to be using its own Wi-Fi diagnostics. We also had an AirPCAP card. And it would collect the packets. And the IPA allows us to show those things like that little treepy, the little picture of the timing, so we could see what's going on with packets. On another screen, we had Wi-Fi Analyzer Pro running. It also had 2 NICs, one on 5 gig and one on 2.4, and we were tracking utilization versus throughput, and we could track and see when we hit utilization got really high, we knew that the iPads were going to fail fairly soon. A little handheld device we used was a Fluke AirCheck. I love Fluke AirCheck. It's fast, it's easy, it has a noise, but you can't really trust the noise because it doesn't show raw packets. It's not a spectrum analyzer, but it has some great little tools. Find tools that work for you. Tools that will let you see layer 1, let you see layer 2, and aren't just the little freebies like Insider's great from MetaGeek, or there's a lot of free kind of scanner tools. What we need is the tools that allow us to see the packets, to be able to analyze the packets. You don't have to use the ones I mentioned here. OmniPeak makes some great stuff from wild packets. You can also look into Wireshark. Wireshark, though it's free, you have to buy a Wireshark AirPCAP card to be able to collect NICs or run under Linux, and it has a little tougher learning curve. But if you don't have much budget, there's other things you can look at. So please help your own practice and use professional wireless tools. So where do we go from here? I gave you the results of what we learned, but we need to move past this little part. This was just a single test. It did one thing, tested throughput, tested video streams. Other issues are going to come to bear when you go looking for what kind of access points you need. Features that are available, manageability, does it link into your current infrastructure? What are the costs? What are the ongoing costs? What's the TCO? All of those issues we didn't touch. We were looking at this one thing. We also didn't show multiple access points. How does a client roam? We didn't test 20 versus 40. We only tested 1-by-1 clients. We could have tested 2-by-2s or 3-by-3s and got entirely different issues. So there's a lot more on the table that we need to do to get a more full picture of the differences between access points. I'd love to hear about what you want. So go ahead and the numbers on the screen, Keith at the Wireless LAN Professionals or Keith at WLAN Pros. Go ahead and send me requests. And of course, the obligatory little add in here. All our testing equipment and personnel are available for hire if you want to run these tests in your facility. For all the individual reports, you can go online. There's a link on the web page and on the screen that will show you where you can go and get the report that lists all the individual reports. There's also a separate video that has just a quick review of each of the access points and how they compared to average. You might want to look at that as well. Thanks for watching.